what would you talk about these days? Obviously AI, language models, and the whole thing. I guess we were kind of progressive when we were planning this. So this was,
sorry, open the microphone.
yeah, it's all.
On this side, we hear it.
So I'll move to the other side and let's move. So when we start planning the panel, this was kind of time ago, so it was progressive then, but let's see what we make out of it then. We started actually thinking about how those language models, ChatGPT especially, could help with education and what the impact to universities, education institutions would be. But I think the situation changed and we're now looking at things in a broader perspective, and I'm looking forward to discuss this with you and the panel. But before we start, and now that people are trickling in, we have a change in the timeline. So after reconsidering a panel with 7 people and everybody talking just for about 5 minutes, maybe 10 minutes, we already exceed the first hour. And so we decided to merge some talks into the afternoon, so we have the complete time for the lunch break for the panel. There will be this coffee break within, so they'll serve coffee around 11 o'clock. So if you're feeling busy and you need okay, whatever, just get out there, grab some coffee, water, whatever, bring it in. If you're looking at desperate panelists, ask them whether they would like coffee as well, and just come back and join the discussion. As for the panel, well, let's meet together. Some of you might already know me. We have Schahram, the old-time founder of this SummerSOC, so I guess everybody knows Schahram. Same with Bernhard, Marco, Ramesh,
Good morning, sir.
Heuvel, and Adrian, Paschke. And well, with that, actually, I want to start about my actual panel presentation, what I started preparing way back when Frank said, oh, Christian, let's do a panel on ChatGPT. Could you think about something? And I thought the nice thing would be just ask ChatGPT itself, so himself, herself, I don't know the pronoun for that. So open a panel about the chances and risks of ChatGPT in computer science education, and it starts talking. So, ladies and gentlemen, distinguished guests, distinguished participants, welcome to this groundbreaking panel or discussion on artificial intelligence, the transformation from, and on and on and on it goes. And every time you're writing something, I write an opening note for MDM next week, and having a hard time writing this one page for the procedures. After that, I thought, why did I use ChatGPT? So you're having something like a sidekick who can help you, and this is obviously something it can do. So now, going for something more into depth, asking about really where's the beef and not just raffling and combining all those 1,000 opening words into something with content. So ask ChatGPT about chances and risks of ChatGPT in computer science education, and then it starts to produce lists of what are the chances and what are the risks. And so with the chances, it says we have personalized learning experiences to students, we have the chance just to have 24/7 support for students, so no matter where they are or when they are, they can interact. And especially if you're looking at times of the pandemic, when you have people joining through our programs which were not local, so actually doing something like examinations where we kind of partnered with students in China and students in the US, attending a lecture in Germany, so which is pretty much in between the time zones, and trying to accommodate support for these people is obviously something which can be done on a worldwide scale easily here. So I guess ChatGPT has a point here. It can improve students' writing communication skills. I mean, this is the next thing. Right now we have a filter about crap science. Well, crap science in the presentation, so if you start reading and saying I don't understand it, it falls into the desk reject. Now everybody on the world can write some kind of English, and maybe a better English than you actually are able to provide just as a hip shot. So ideas will count, and not necessarily your style of writing, or not. We had this discussion in the morning during breakfast, so I guess this will be an interesting thing to catch up. Engage interactive learning experience as well. I'm not sure about high-quality text methods. I mean, I went to computing things and learned computing in the 80s. So using a command line interface is still some kind of a sexy interface to me, but I guess most people have different experiences when they are interacting with computers. Risks, it's fair, it produces some kind of risks here, so it may not be able to understand and respond to every student's query. Honestly, me neither. It may not provide the same level of guidance as human teachers. It depends. So I guess there's more patience in a program than it might be in a person. It might not be able to adopt, the very late students, but this might be something where you have a loss of objectivity in there, or maybe support biases. It might discourage social interaction, collaboration among students. Well, we're talking about computer science programs, so everything that brings people to communication anyway will help, I guess, to that degree. And in summary, there are benefits as well as pitfalls. So this was actually how I wanted to start the panel when we talked about it. But now what has happened? Meanwhile, we have this moratorium, or the call for moratorium, say, stop training models. And then the first thing is, you say, okay, maybe this comes from a guy whose model has not yet been trained enough, so he says, stop training all the other models so I can catch up, which would be a rational thing. Or is there something really in Pandora's box that we opened and we will never get it back into the can? And then John Grant says it's a nuclear bomb, and everybody has it, so it comes to the traditional nuclear bomb. There are roundtables, the EU, government, everybody does this. Well, obviously in the EU, the main worry is that others might be ahead, and so it's not about assessing the technology and what to do with it, but we have to catch up and find out that it was a miserable idea behind, I guess. So, but if you're looking at the media and news recently, what do you find out? Nobody really seems to care. So this was this initial wave, and I will kill us, whatever, and what goes on? I mean, we're here on beautiful Crete, we're looking forward to some excellent food. We had some excellent food before, so life's not that bad, doesn't it? So now the question is, what is this AI thing doing to us? And actually, there was one great fear I had when in 2010 I attended Intelligent Environments, and they had a movie picture they showed. It was called The Singularity, talking about the point when artificial intelligence will become more intelligent than regular or human-based, assuming that humans are kind of the peak of the normal intelligence out there, or biological intelligence, so to speak. And then I started becoming kind of afraid and talking to people, Anna Schmidt, Paul Lukowitz, a number of people in AI, and they always said, oh no, AI won't start, to say, I only need that much of biomass to take care about me and kill all the others because they compete about resources. It'll be complexity or misunderstanding, modeling that will somehow hinder things. And so I became a bit more relaxed and continued, drinking wine, eating, and doing teaching, computer science, occasionally some research. But looking at what GPT can do and all the problems people now starting to discuss, my voice came back a bit. And some of you might remember this remarkable movie 2001, A Space Odyssey. And when Dave is outside an exploration vehicle and he wants to come back to the spaceship, which is controlled by Hal, the computer, and he says, Hal, please open the door. And Hal says, sorry Dave, I cannot do that because Dave is somehow interfering with the mission. And there was something in the paper where the American Army denied that it happened, where a drone went berserk and tried to kill the commanding officer or the commando center because they said, okay, abort mission. And the drone was running for its mission, saying, okay, I have to first kill this command center because it says abort mission in order to complete the mission, which is pretty much a similar situation that happened in 2001 in this movie picture when the computer found out, and over here Dave and Frank talking about shutting down this computer because they wouldn't trust it any longer. Then he decided this is the time to get rid of the human beings being blocking the mission goals. And this is where we are guessing could also be heading. And still my worries are back. Nobody is here to soothe them. And so I hope for some discussion in the panel, people helping me getting back to my life. And so what's your take? Is this fine for education? It's good for writing papers. How to handle those zillion papers for people with ideas who are now able to write English from a scientific perspective? Is there a difference asking a senior colleague or a senior AI model? So is this okay? So if we are supervising our students, why shouldn't students take some smarter AI than us in order to do so? Or will AI kill us all and all these efforts we have are gone, and so we should live for the next day and just enjoy Earth as it is, like we have it? And again, we have this panel with Schahram, Bernhard, Ramesh, Willem-Jan, and Adrian, who will first provide some first key things in the larger, broad view on the whole thing, and then we have hopefully enough time to discuss this. And with that, I want to hand over to Schahram first.
Christian, can you change the slides?
Oh, you can do. You have this.
It's you.
Oh, this is this one.
Wow!
Ah, magic!
I didn't know that.
Well, you know, I'm doing distributed systems, so this is kind of a secret thing.
So I'm going to talk about LLMs, intelligence, brains, consciousness, and space-time, just to amuse Frank.
Next 5 hours.
The next 5 hours. So basically, the large language models, they do these activities, data collection, pre-processing, then they create tokens, so breaking down the text into pieces, then they do the model training with deep learning networks, then they do what they call self-attention mechanisms, bringing in weights, feed forward neural networks, and then that leads to a statistical prediction of next words. So that's the very calm interpretation of what LLMs are actually doing, right? So there is not super much magic behind it, it just mirrors back what has been fed into, which is, as the name says, large language models, many text forward. So, and since the comparison to the intelligence of the human is done, I want also to track back a little bit and look into the human body itself. So the human body is a complex system, actually comprised of several different subsystems. The skeletal system, the nervous system, cardiovascular system. That's basically our infrastructure system, right? And this infrastructure goes more. I mean, we have even more. We have the lymphatic system, endocrine system, which is for regulation. So, and the nervous system, which is mostly compared to the brain. That's why I'm bringing this here. With the spinal cord, the nerves, the cranial nerves, the spinal nerves. With the brain as a control center, has 86 billion neurons. So it's a vast, a huge computational entity, much more capable than what we typically have there. But it doesn't stop there. So the body is extremely complex because we also have the cardiovascular system with the heart at its center, and the heart also has 40,000 neurons. This is less known, and it has also even sensors in it, even more or less known if you like. It has a light sensor. People are still wondering why is the heart, which is internal, has a heart sensor. And the gut also has 100 million neurons. So the gut is also a computational center. So we have 3 computational centers. So, and these 3 centers constantly communicate with each other. So it's not just one kind of computational center, as most people think it is, with the brain at the center. They make the equivalence of the cloud being centralized. No, the body, which is the, let's say, crown jewel of evolution, has much more complexity going on. And then we have also the lymphatic system for endocrine system for regulating and creating the immune system. Now, how does that connect to intelligence? So the problem with intelligence is that, or the challenge is that Turing proposed this Turing test in the 50s with this paper titled Computing Machinery and Intelligence, and it aimed at providing a practical way to evaluate machines' ability to exhibit intelligent behavior. And if a machine could carry out on a conversation with a human being without the human realizing that they were interacting with a machine, he would say that this machine demonstrates intelligent behavior. And the problem, as I stated here, is that we basically became lured into the illusion that if something is as if, it is like is. Meaning that, okay, this then is intelligent. But there is a huge differentiation here. As Mari Minsky pointed out, the Turing test is a joke. So it's quite fun. Look at this video on YouTube. He explains why this is actually intended as a joke, because it was just trying to explain something. So don't get too much carried away with this. And the reason is that mainly these large language models, they lack in what we call causation, meaning understanding the deeper reasoning behind this. And there is a paper published 2 weeks ago by Schahram and his group, and large language models infer causation from correlation, and with a lot of samples, etc. And surprise, these models achieve almost close to random performance on the task, which is very, very interesting, right? Because it gives the illusion of causation in many cases, but I'm sure other colleagues will talk about the hallucinations, etc. as well. So this is just no causation. I want to link that to the brain. Again, because the brain is extremely powerful. It's a computing device in the sense that can be trained on any data stream. So in this book, with the newest research from Stanford, it is shown that the brain can be trained on any data input and process it and integrate it. So we can basically learn, in other words, to see with our tongue and understand things with our skin. So these things are possible. So the brain is much more capable that we actually are aware of. One famous person here, Neil Harbison, is a cyborg who has this antenna sending audible vibrations to his scalp because he's colorblind, and this basically made him to learn, his brain to learn electromagnetic radiation, phone calls, and many other things that people can program. So we are extremely adaptive, and we don't have to train so long with such computational power. And finally, the interesting aspect of a human compared to the traditional AI stuff is that we have what is called qualia in research. Qualia and experience. So our human experience is really fundamental to our conscious experiences. And this is what is described in research as the hard problem. It's actually the number one in the most difficult scientific problems. What is consciousness? What does it actually mean? And the qualia is like, what is the taste of chocolate, the smell of coffee, the joy of seeing your baby? These things make us human, and these are impossible to map into traditional AIs. And these qualia always leads to a rewiring in our brain. This leads to a plasticity in the brain. And this is something that we don't have in this AI approach. We are constantly rewiring ourselves. So finally, I want to connect that to the deeper consciousness, because I was basically mentioning Turing before. You remember that Turing made this as if this is, so this intelligence notion, basically many people now conflate with consciousness. So there seems to be a linear idea. If it becomes more intelligent, it becomes automatically conscious. And this is the crux of the problem, because this is simply not true. You can have super intelligent machines, and we have them also now, but they are not conscious. This doesn't mean that they are conscious, because consciousness is fundamental for our experience. As we learned yesterday, space-time is not fundamental, although it's a persistent illusion. But this is also not new. It has been said 4,000 years ago already. All mystical traditions say the same. And also consciousness is fundamental. Also the people involved in quantum science basically said consciousness is fundamental, as Max Planck says here. We cannot get behind consciousness. Everything we talk about, everything that we regard as existing postulates consciousness. Also Schrödinger, consciousness cannot be accounted for in physical terms. Absolutely fundamental. So, to sum up, I think what we need more here in computer science, in particular in AI, is to be more humble, to understand that as nature has evolved, we have a fantastic blueprint of what actually intelligence is, or could be even. Even if in our own bodies, we can see what our own brain with the different data stream input is capable of doing, and we should be more humble in understanding these things before we make these super big claims. And I want to point to a very interesting multidisciplinary conference called the Science of Consciousness, which talks about these aspects that I'm talking about from different perspectives, biology, computer science, and the like. Thanks very much.
I only prepared 4 slides with a few topics, and let's start. This is my take on large language models. I guess this we discussed. Where's this? Oh. Yeah. So we discussed already those models. Read whatever they get. It's mostly text-based. They take everything from the web. They compute a model by iterating and building up a probability model. There are several examples. So most known is ChatGPT. It's a chatbot that has at its core a large language model that uses the build probability model to look basically what is the next word to generate to build up text compositions, and somehow to communicate similar to humans. There are others like Copilot, for example. At the heart, it's also a large language model which is trained differently. There's the Codex, a knowledge model on how to organize a code and code snippets. And this is around almost for 2 years and is heavily used by programmers. Yeah? And for some reasons, maybe we can discuss later on in the panel and with the audience, I don't understand why there's a big wave now with ChatGPT, and with Copilot it wasn't in that manner. So now people are saying you don't have to program anymore, but Copilot was around even earlier. Yeah. And this was targeting the coding. Yeah. Okay, so now for let me work a little bit on what does it mean to be similar to humans, and I guess this goes also in the direction of what Schahram was telling us. So chatbots that communicate like humans. Now, what properties do we see that chatbots in that respect do they have? What can these machines, let's call them machines, do better than humans? Well, one has already been said. It is they consume vast amounts of data, and they can do this much better than we can do. They compare, assess, review, estimate those data volumes and the snippets inside, and they have with this a much higher coverage than humans have. Then the question is, then what humans lose to these machines? We should give give to the machines what they can do better, i.e. those things mentioned before. And what should we keep? Yeah. So from my point of view, it is we should keep innovation, and I guess this is close to what those definitions of consciousness is. Instinct, yeah. Some knowledge on similarities. Also, I know that you can train similarity and search for similarities and then work on that. Symmetry, similarities, and gut feeling. Yeah, this is my determination for some kind of consciousness. Yeah. Or some aspect of consciousness. Further on, do they show true intelligence? It seems like yes, but sometimes the systems are wrong. They have no references, they have wrong data, and they have self-generated data, sometimes from wrong data that got into the system or was generated by the system itself.
Which is typically human.
Which is typically human, and then there is that notion of hallucination, yeah, which basically builds on those things that go wrong. And what is missing most is explainability. Yeah, so we don't understand and we don't get the right information on what has been proposed. Yeah. So from my understanding, to make it short, do they show consciousness? Those machines seem to show no consciousness from my point of view. And the reason for this is basically the arguments given before. So as a result of that short discussion, we have the following consequences from my point of view, consequences for teaching, for industry and for research, and also for our personal and private area. Those systems may still, or most probably, are useful in some, I call it, non-exact areas, yeah? Where a first draft is important, a starting point or a first take is important. So what do we know from our volume of data about a specific issue? And is there a first assessment? And then we start from that and try to find out what is right and what is wrong. But it is certainly not useful wherever some kind of completeness, integrity, correctness or security is key. Hence, those systems are already banned in many companies. The companies say, well, for some reasons we cannot take the result because it's not secure or not integer what we get. And also when we give our prompts to the system may understand what we are doing, and for those reasons in many companies LLMs and ChatGPT especially are banned. But I think that for some domain areas we can specialize those systems and have some focus on that very domain area and to teach the system. And so when you look into the journals and the newspapers, there's already a new job description. It's called the prompt engineer. And I have seen websites where I can put my prompt and sell it to others.
Sure.
Yeah. So this is sometimes it's called the hottest job currently on Earth. Basically, how to train those systems. Yeah. Okay, that's my first take. Thank you.
Absolutely, it was to be expected.
And it looks clear to me.
We
lost this. Okay. Is this one the beam now?
Hello.
At least I hope. Okay, I'll move my hand. So I actually wanted to continue on the topic that you were talking at the end, like what does it mean for us? And actually the point to you is like, what's going to happen to your job? Right? When you look at these kind of things, you always think, oh, people are going to lose jobs, but what about yourself? Right? And the first question is, how much are you working per week, per year? Do you have an idea how much you're working or average you're working? So automation has traditionally taken away hours of work to people. So after the first industrial revolution, what happened is that people could work much less because automation was making them more efficient. And there's a famous economist called Keynes that in 1930 looked at the trend of working hours in the world and he saw that it was going down linearly. So basically we're going from 3,000 hours per year of work to 2,500. And he said, well, if this line goes on like this, and why shouldn't it? By 2030, everybody's going to be working 700 hours per year. That's 3 hours per day. How many of you work 3 hours per day? PhD students doesn't have to answer.
You didn't say at most 3 hours, right?
Yeah,
3 hours.
Good. So if you